Hello, in this video we will discuss interpolation, extrapolation and some concept related to these topics. So consider y equal to f of x be a discrete valued function. Let x0, x1, x2, etc. xn be x values and y0, y1, y2, y3, etc. yn be corresponding y values. I will explain the concept of interpolation with the help of an example. So consider x values 2, 3, 4, 5 and corresponding y observations 10, 15, 18, 19. Now, if we wanted to find y value corresponding to x equal to 4.5, or if you wanted to find y value corresponding to x equal to 2.1, this process we call it as interpolation. Or in general, if x values are x0, x1, x2, etc. xn and y values y0, y1, y2, etc. yn, and if you wanted to find y value corresponding to x value where x lies in the range x0, xn, or we say it as x0 less than or equal to x less than or equal to xn. So process of finding such y value we call it as interpolation. Here x value should lies in the given range of x. In the example, we were supposed to find y value when x equal to 4.5 and 2.1. Here 4.5 as well as 2.1 lies in the interval 2, 5 because the limit for x is 2, 5. Now if you wanted to find y value when x equal to 1 or when x equal to 5.3, what is y value? So that process we call it as extrapolation. Here y value we are supposed to find when x equal to 1 and 5.3. This 1 and 5.3 lies outside to the interval 2, 5. So such process we call it as extrapolation. Now we will discuss some methods to find y value corresponding to given x value. So we have two methods. One is Newton's forward interpolation formula, another one is Newton's backward interpolation formula. Newton's forward interpolation formula we have yp or y equal to y0 plus p delta y0 plus p into p minus 1 by 2 factorial delta square y0 plus p into p minus 1 into p minus 2 by 3 factorial delta cube y0 plus etc. p into p minus 1 into p minus 2 etc. p minus n minus 1 by n factorial delta n y0. Here p equal to x minus x0 by h, where x0 is initial x value in given observation, y0 is corresponding y observation in given set of data, h is difference between x observations. We know that Newton's forward and backward interpolation formula we can use only whenever data is given of x values should be of equal interval. Means distance between each x observation, neighboring x values should be same. That we denote it as h. Similarly, we have Newton's backward interpolation formula, that is y or yp equal to yn plus p del yn plus p into p plus 1 by 2 factorial del square yn plus p into p plus 1 into p plus 2 by 3 factorial del cube yn plus etc plus p into p plus 1 into p plus 2 etc. p plus n minus 1 by n factorial del n yn, where p is equal to x minus xn by h. Here xn is last x observation in given set of data and yn is last y observation in given set of data. H is interval length, x is point at which y to be determined. In Newton's forward interpolation formula as well as Newton's backward interpolation formula. X means point at which y to be determined. So these two formula we will use to find y value corresponding to x observations. Now delta y naught, delta square y naught, etc. These delta values we will get from the forward difference table. Similarly, del yn, del square yn, etc. we will get from the backward difference table, which we discussed in the previous video. Now we have to think when to use Newton's forward interpolation formula or when to use Newton's backward interpolation formula. So both formula we are using whenever x values are of equal interval. So when to use forward interpolation formula and when to use backward interpolation formula, I will explain with the help of example. Look at this example. If you wanted to find y value corresponding to x value 2.5, or if you wanted to find y value corresponding to x equal to 7.5. So which formula is useful to find y value when x equal to 2.5 and which formula is useful to find y value corresponding to x equal to 7.5? Now I have divided this table into two halves. In first half we have 4 observations, x value 1, 2, 3, 4. Second half we have again 4 observations, 5, 6, 7, 8. When x equal to 2.5, this observation of x lies in the first half of x. When x equal to 7.5, this observation lies in the second half of the x. So if x value lies in the first half of the table, then we use Newton's forward interpolation formula. Similarly, if x value lies in the second half of the table, we use the Newton's backward interpolation formula. This will be more appropriate. So with this concept, we will find y value corresponding to given x value, and we will discuss more problems in upcoming videos. Thank you.